Welcome to the lesson Mechanical Design Part 3, Bearing. The main function of a rotating shaft is to transmit power to one end of the line to the other. It needs a good support to ensure stability and frictionless rotation. The support for the shaft is known as bearing. The shaft has a running feet in a bearing. All bearings are provided some lubrication arrangement to reduce friction between shaft and bearing. Bearings are classified under two main categories: plane or slider bearing, in which the rotating shaft has a sliding contact with the bearing, which is held stationary. Due to large contact angle and area, friction between mating parts is high, requiring greater lubrication. Rolling or anti-friction bearing. Due to the less contact area, rolling friction is much lesser than the sliding friction. Hence, these bearings are also known as anti-friction bearing. Ball and roller bearings. Due to low rolling friction, these bearings are apt called anti-friction bearing. Frictional resistance considerably less than in plane bearing. Rotating, non-rotating bearings, separated by balls or rollers. Ball or rollers has rolling contact and the sliding friction is eliminated and replaced by much lower rolling friction. In plane bearing, the starting resistance is much larger than the running resistance due to absence of oil film. In ball and rolling bearings, the initial resistance to motion is only slightly more than their resistance to continuous running. Hence, ball and rolling bearings are more suitable to drives subject to frequent starting and stopping as they save power. Owing to the low starting torque, a low power motor can be used for a line shaft running in ball bearing. Types of roll bearing. Single roll deep groove ball bearing, incorporating a deep hardened raceway, which makes them suitable for radial and axial loads in either direction, provided the radial loads are greater than the axial loads. Single roll roller bearing. Roller bearing have a greater load carrier capacity than ball bearing of equivalent size, as they make line contact rather than point contact with their rings. Not suitable for axial loading. Cheaper to manufacture. Used for heavy and sudden loading. High speed and continuous service. The ball and the roller bearing consists of following parts: inner ring or race, which fits on the shaft; outer ring or race, which fits inside the housing. Ball and roller arranged between the surfaces of two races. This provides rolling action between the races. The radius of the track of balls is slightly greater 5 to 10% than that of the ball themselves. Note that the rotating surface rotates in opposite directions. Cage separates the balls or rollers from one another. The advantage of the ball and the roller bearings are high cost. They cannot be used in half and greater noise. In a deep groove radial bearing, the race dimensions are close to the dimensions of the balls that run in it. Deep groove bearings can support higher loads. An angular contact ball bearing uses axial asymmetric races. An axial load passes in a straight line through the bearing, whereas a radial load takes an oblique path that tends to want to separate the races axially. Therefore, the angle of contact on the inner race is the same as that on the outer race. Angular contact bearings had better support, combined loads, and the contact angle of the bearing should be matched to the relative proportions of each. The larger of the contact angle, the higher the actual load supported, but the lower the radial load in high-speed applications such as turbines, jet engines, and dentistry equipment. The centrifuge forces generated by the balls changes the contact angle at the inner and outer race. Cylindrical roller bearings are designed to carry heavy radial loads. These bearings are made with a single row, two rows, or multi-rows of rolling elements to meet an application's radial and requirement. Available in many standard series and configurations, they are widely used in multiple industries. The combination of high load capacity, moderate speed rating, and industry interchangeability make it one of the most popular bearing designs. Tapered roller bearings are rolling element bearings that can support axial forces as well as radial forces. The inner and outer ring raceways are segments of combs, and the rollers are tapered so that the conical surfaces of the raceways and the roller axis, if projected, would all meet at a common point on the main axis of the bearing. This geometry makes the motion of the combs remain coaxial, with no sliding motion between the raceways and the OD of the rollers. This conical geometry creates a linear contact path, which permits greater loads to be carried than with spherical bearings, which have point contact. This type of bearing is recommended with alignment of the shaft and housing is difficult and the shaft may flex. The outer ring has a spherical raceway and its center of curvature coincides with that of the bearing. Therefore, the axis of the inner ring, balls, and cage can deflect to some extent around the bearing center. Pressed steel cages are usually used. Since the contact angle is small, the actual load capacity is low. Oil is generally used to lubricate rolling bearings when high speeds or operating temperatures preclude the use of grease. Excessive heat has to be removed from the bearing position. Adjust components are lubricated with oil. To extend bearing surface life, all methods of bearing lubrication that use clean oil are acceptable. These include the circulating oil lubrication method, the oil jet method, and the oil air method. When use the circulating oil or oil air method, accurately dimensioned conducts should be provided so that oil flowing from the bearing can leave the arrangement. Thank you for your learning.